Hello friends, today we are going to see about the experiment determination of the specific resistance of the given coil of wire using Carey-Foster's bridge. For this, the formula is rho is equal to x pi r squared by L. So x is the resistance of the coil and pi constant r square. In this r is a radius of the coil and L is the length of the coil. To find the specific resistance, we have to find the x value, that is resistance value. For resistance, this is the formula x equal to R plus L1 minus L2 into Rb ohm. Okay, so here before finding this resistance of the coil, we have to find the resistance of the given bridge wire. Okay, so to find the specific resistance of the given coil of wire, we are using a Carey-Foster's bridge. So this is the meter bridge, and what are the apparatus required means, along with this bridge, one high resistance box, one galvanometer, one constant resistance P and another constant resistance Q, and one variable resistance S, and the unknown resistance is the given coil of wire. So this is the given coil of wire, the steel wire is given. For this, we are going to find the specific resistance. So now discuss about the connection, circuit connection. So see, so this is the meter bridge. In that, here we have a center terminal. So it is connected to the high resistance galvanometer and jockey. And see the apparatus here. So this is the center terminal. From this center terminal to high resistance, this is the high resistance, and from high resistance to galvanometer to jockey is connected. Okay, and to this center terminal, here we have, that is the left side of this center terminal, here we have a pair of terminals, that is see the circuit here, and these two are the pair of terminals. In between these two terminals, we have to connect the resistance box P. Okay, so see the apparatus, and this is the pair of terminal. From in between these two terminals, we have to connect the constant resistance P, and from this terminal, at the end of the P, here we have the connection to the battery positive. Okay, so this from this terminal, that is at the end of this resistance, we have to connect a battery positive. But in this apparatus, we have the another single terminal nearby to this, a pair of terminal. Here we have the connection in between these two. So from this single terminal, we can make a connection to the battery positive. Okay, and after this battery connection, we have a pair of terminal. It is connected to the variable resistance. And see this apparatus, after the battery connection, here we have a pair of terminal. It is connected to the variable resistance box. So while connecting this variable resistance box, the strip should be opened. Then only the circuit will be completed. Otherwise, there is no proper circuit connection. Okay, so remember to remove the strip, open the strip. And make the similar connection to the right side also. So here in between these two terminals, connect the Q variable, another constant resistance, and from this end of the Q, make the connection to battery negative, and at the end of the right side, here we have two terminal. It is for connecting the unknown resistance coil. Okay, so for the first table, to find the resistance of this bridge wire, we have to keep the strip closed at the end of the left side. So see the right side connection. So this is the center terminal, and to this center terminal here we have a pair of terminals at the right side, and this should be connected to the another constant resistance Q, and from this free terminal it is connected to the end of the Q, and from this free terminal we have to make the connection to the battery negative, and end of this right side here we have two terminals. So before taking the resistance of the given coil of wire, we have to find the resistance of this bridge wire. So keep this terminal closed. So the strip should be closed for the first table. Okay, after making all the connections, just ensure the circuit whether it is correct or not. So how to ensure this means, just keep the jockey on the left side of the bridge, means the galvanometer shows one side of reflection. Okay, here the reflection is to the right side, and place the jockey to the opposite side, that is right side end, means the galvanometer shows left side deflection. So when we place the jockey opposite sides on the bridge wire, means the galvanometer shows opposite side deflection. So we can confirm the given circuit is correct. In battery, two voltages maintained throughout the experiment. Okay, and in the resistance box, constant resistance box P and Q, we can maintain the 1000 ohm resistance as a constant resistance. Okay, right. And to find the resistance of the given bridge wire, use the first tabular column. So in the first column, resistance in the box R. So in the variable resistance box, we can fix the resistance as 0.1, 0.2, 0.3, 0.4 like this, using this variable resistance box. Okay, so we can take any 5 readings from 0.1 to 0.5 or 0.6 to 1 ohm. And the second column, balancing length with R in the left gap. So here the resistance box is placed at the left gap of the bridge. Okay, so at this position we have to find the balancing length by moving the jockey on the bridge wire from left side itself. Okay, now fix the variable resistance as 0.1 and move the jockey on the bridge wire from left side, means we will observe a deflection on this galvanometer. Okay, while continuously moving the jockey on the wire, means at a particular place it shows 0 deflection. Okay, when it is reaching 0 deflection, measure the balancing length. Okay, it is 40.7 like this. Okay, so to take the reading, use the scale. It starts from left side to right side. Okay, and jockey moving also from left to right side only. Right, and write this reading in the second column when R is in the left gap, and change the resistance in the resistance box 0.2, and again move the jockey on this bridge wire and see the variations on the galvanometer. At a particular balancing length, it again shows null deflection. Okay, and when it shows null deflection, 0 deflection, take the balancing length again. Okay, and write this balancing length here now 37 point something, so write in the second row. Okay, similarly take all the readings, that is from 0.1 to 0.5, you can take the readings and just replace the resistance box from left side to right side. Here when connecting this resistance box at the right side, the strip should be opened and here it should be closed. So just interchange the connection and take the balancing length in the as like in the previous manner. Okay, and write the resistance in the right gap when with R in the right gap. Okay, after completing these two columns, do the calculations for RB. RB is equal to R divided by LA minus LB. That is, it is a difference. So LA difference LB. Okay, so you can write the 10 power 2 in the top of this column. So don't write within the tabular column. Okay, if it is writing here means it is common for all the readings. So RB is over. And in the second table, we can measure the resistance of the given coil of wire X. So for this, the same procedure is followed. That is, the first column is resistance in the box R, and in the second column with R in the left gap, and third column with R in the right gap. So here, when R is connected in the left gap, the given coil of wire is connected in the right gap. Okay, then with R in the right gap means here the coil should be connected in the left gap. Okay, so anyway, when R is left means we have to write this column only, and R is a right gap means we have to write the balancing length in this column itself. Okay, so the same procedure is followed for this table also. That is, keep the resistance as 0.1 as earlier, and make the movement of jockey on the bridge wire, and find the null deflection and write the balancing length. Okay, for all the variable resistances as in the previous table. And this is the formula for X, that is R, the first column, and this is the L1, then this is L2. So the formula is R plus L1 minus L2 into RB. Okay, so the RB is taken from the table 1. Okay, for measuring the X with the resistance of 0.1, you have to take the RB value from this one. The individual RB value should be taken for the calculation of X. Okay, then finally take the average of this X column, means you will get the average resistance of the given coil of wire. Okay, then next one, radius of the coil. To find the radius of the coil, use a screw gauge. So before taking the reading, we have to find the what is the error present in the screw gauge. If it is positive error means how many divisions are there, and convert this error into correction. So when multiplying this error into least count means we can find the zero correction. Then next one, fix the screw given coil of wire in the screw gauge and observe the pitch scale reading and head scale reading, and these are all formulas. For observed reading, the formula is pitch scale reading plus HSE into LC, and for correct reading, observed reading plus or minus zero correction. If error is positive means the correction is negative, so we have to subtract this value from this observed reading for correct reading calculation, and take the average. That average is the mean diameter. So we need radius, so just divide this value by 2 means you will get the radius of the given coil of wire. This is R. So we now know all the details, so we can find the specific resistance, that is a resistance per unit length across unit area of cross section. So rho is equal to X pi R squared by L ohm meter. So X is taken from the average of a second table, and this is a pi value, constant value, and R squared. So we can take the radius of the coil, so it's square, then divided by length of the coil. By simplifying this value, we can get the specific resistance. Rho is equal to this much of value. So generally the specific resistance of the coil is expressed in 10 power minus 7 ohm meter. Okay, so this is the final value of specific resistance for the given coil of wire. Here steel is used. Thank you.